Now let's have a look at another example involving shading. This time, let's do the diagram for A2. So we have three A's, so the conclusion is going to look like this. All S is P. This time, though, the M's are in the second figure, which means they're both in the predicate position of the minor and major premises. Here's the major premise, so we put P. Here's the minor premise, so we put S. Here's our copulative verbs, and we fill in with the quantifier there. So the resulting argument is all P is M, all S is M, therefore all S is P. Now, if you think about this argument for a moment, you can probably come up with a counterexample using particular terms for S, P, and M, and the counterexample would show that if the premises were true, the conclusion cannot be false. So here's one possible model that serves as a counterexample. All cats are four-legged animals, all dogs are four-legged animals, therefore all dogs are cats. So if you think about that example, it's pretty clear that the two premises can be true, but the conclusion doesn't necessarily follow, as we say. In other words, this model has shown that the argument has a counterexample, and if an argument form has a counterexample, then it has to be invalid. The problem with that method is that it relies a lot on ingenuity. In other words, there's not an algorithm behind it. And so, if we happen to be having a bad day creativity-wise, we may not be able to think of a model that serves as a counterexample. So the Venn diagram is a much more reliable method because it is algorithmic and therefore does not depend on whether you're having a good or bad day creativity-wise, right? All right, so as is the case with our previous example, we're going to go through the steps for a shading, and I'll talk you through this one, and you'll be able to see how an argument that is invalid looks with a Venn diagram. Notice we're still focused on the shading, so we haven't started doing any diagramming of x's yet. So I'll do some more examples after this that will show you how to get the x's in. All right, so notice that as in our first example, the major and minor premises are both universal, so that means that they're each going to require some shading. So if we were to draw diagrams for the major premise and the minor premise separately, we would see a standard diagram for an A, right? All P is M. The region of P outside of M would have to be shaded. So in this case, we can go ahead and put that on here, and as before, we ignore the S circle because we're diagramming the relationship between P and M based on the information that's given to us explicitly in the major premise. Now we move on to the minor premise, all S is M, and here again we want to diagram all S is M. I'm going to change the color so you can see. We're going to diagram the region of S outside of M. So notice there's some overlapping shading. It's hard to see when these colors collide, but you can see when we diagram the region of S outside of M, we've diagrammed all S's or M's. And notice all the S's there are going to live inside this little zone, this sort of eye-shaped zone, right? So we've done our diagramming properly. Even though there's some diagramming, even though there's some shading that overlaps in this overlapping region, it doesn't really matter because once it's shaded, it's just shaded, right? Okay, so now notice what's happened in this diagram. We've got our shading done for the two premises, but the shading by itself does not make it the case that all S's are P's. Notice, because this region here is left unshaded, that means that there could be S's that are not P's. It so happens that these S's that are not P's might be M's, but that is not really the issue because the conclusion is claiming that all S's are P's, and that is not supported by the information that's given in the two premises. Or to make that long story a bit shorter, if the premises were true, it's not the case that the conclusion cannot be false. And because of that, what we see is that this argument is invalid. Stay tuned for some examples of shading combined with x's, and then we'll talk about indefinite x's and the double duty rule.